Hello, dear learners. When you are attending a maths lesson with me, get ready with a pen, book, and your calculator. Today, we are going to see grade 12 financial mathematics. First, let's have a look at your formula sheet to see where are the formulae that we use in financial mathematics. Here is your formula sheet. You can see here in the beginning, it's only the grade 11 formulae that you have used. You know these 4 formulae. Then these two below the sequence and series formulae, you have the grade 12 financial mathematics formulae. So we are going to discuss about all this today. Okay, so let us get used to the grade 11 formula first before we go to the grade 12 formula. In grade 11, you were learning these 4 formulae. That is A equal to 1 plus Ni, A equal to P times 1 minus Ni, A equal to P times 1 minus I to the power N, A equal to P times 1 plus I to the power N. In all these formulae, you are using the same letters, same variables. So A is always, in all the 4 formulae, A represents the final amount, P represents the principal or the present actually amount, and I is the interest rate, N is the number of years. Then why these different formulae? So this formula is used, this first formula is used only when the question talk about simple interest. Also when the question talk about hire purchase, then you use this formula. You use this formula only for depreciation. So these two formulae are for depreciation questions. When the question talk about depreciation, then you use these two formula. So depreciation means the value is depreciated after some time. So that is why these two formulae have a negative here. So this is used when the question says straight line method. Then you use that formula. You use this formula when the question says reducing balance method. Then you use this formula. So these are the two formulae for depreciation. Now this one is also the amount increases after some time. So the plus formula, it's used when the question says compound interest, or if the question talk about inflation, then you use this formula. Also if the question talk about growth in population, growth in number of bacteria, such cases, then also you use the formula A equal to P times 1 plus I to the power N. So all the 4 formulae, how these are the variables used. Now in grade 11, you also learned another formula which is very important, that is to convert from effective interest rate to a nominal interest rate and nominal to an effective interest rate. So IE represents effective. So in this case, the effective for annually. So here the effective is annual rate here. Here nominal, the M can, if the M is 12, it will be a monthly rate. If the M is 4, it's going to be a quarterly rate. So I norm represents any nominal rate. So that is also an important formula you learned in grade 11. Okay. Now in all these formulae that you learned in grade 11, you have one principal amount. You use it. Then if it is invested in simple interest, you get a future value a final amount in the future. The same applies here. Compound interest formula, you invest something, then you get a final amount after some time. So you only have one principal amount. Here in depreciation formula also, you this P stands for maybe if you're buying, so depreciation already happens with the items bought. You bought a car, then after 5 years the car doesn't have the same value, it's now depreciated. So the P is the price now, then A will be the price of the car after few years, which is also called so in depreciation formula, the A is also called book value or scrap value because it's a depreciated amount. So in all these four formulae, we use P once. In depreciation formula, you use the P to buy something now, then you get an amount in the future when you sell it. In these other two formulae, you invest or you have sum of money, then you get interest on it, then you get a amount in the future. So only you are taking the money only once. But now in grade 12, you are going to see problems where you invest more than once. That means those type of problems are called annuity formula. Annuity problems. So we use annuity formula for that. Annuity means where this annuity means equal payments. So in here you only have one payment, but in annuity formula you will have equal payments. So in an examination question, for you to understand when do you use the annuity formula and when do you use this formula with A and P. So you look whether there is any equal payments. So we are going to see questions now. So you check whether there are equal payments. Now you must decide on the formula. There are two formula that I was showing you in the formula sheet. One is F equal to, other one is P equal to. F equal to, that is called future value formula. Future value formula. This P equal to, that formula is called present value formula. So you use the future value formula when you are making equal payments, then in future you are going to get a sum of money. That's when you use the future value formula. For example, investment. You are investing 100 Rand every month to have a sum of money in future. That is that situation you use future value formula. Present value formula, that you have a sum of money now at present, then you may get the money every month or every quarter, or you pay back. Now you take a loan, for example, so you get a sum of money now, a loan that you have taken to buy something, then you are paying off. So in future you are paying, you finishing the payment. That is what happens in present value. So the sum of money is at present, not in future here. In the case of loan, the money is now. You took a loan to buy a car, so you have the money at present to buy you bought the car now, then you are finishing off. So these are reducing balance problems, present value, because we are finishing off the money here that you have at present. But in future value problem, you will have a sum of money in future. Now these two different formulae, let us go in detail about the two formula. First one, the future value formula, f equal to x times 1 plus I to the power n minus 1 divided by I. So f is the future value here, future value. I, as you no, x is the next one. Let's go to x. X is the equal payment, whether you are paying monthly or quarterly. That equal payment is called x, which was not in the above formula. There was no equal payment, so x is only in future value formula and present value formula. And I represents the interest rate, no change in that, it's the interest rate. And n represents the number of payments. It's not the number of years anymore. This represents the number of payments. N represents number of payments. Now let me also write the present value formula here. Present value formula is P equal to x times 1 minus 1 plus I to the power negative n, the whole divided by I. So x is still equal payments, n is the number of payments, I is the interest rate, p is the present value. What the sum of money that you have at present. So that is the present value formula. So we use these two formulae only when there is equal payments. So the important goes here with equal payments. When there is an x is called the equal payment here. Now we will know about this formula in detail when we do problems. So let's go to problems now. Let's go to question number 8. A farmer bought it. So this is a full question in the examination. I have taken it as it is from the examination paper. So normally it's question 8 in paper 1. So that's why the number is 8 here, because it's from an examination paper. Now as you can see, the total marks is 16. So here we use all the formula that I have mentioned above. So first question, let's see which formula we can use here. A farmer bought a tractor for 980,000. The value of the tractor depreciates annually at a rate of 9.2% per annum on the reducing balance method. So the moment you see the reducing balance method, you must already decide on the formula. So which formula goes for that? Reducing balance means the formula is now, it's a depreciation formula because the farmer bought a tractor. It reducing already tells you it's depreciates. Using the reducing balance formula, that means the formula is A equal to P times 1 minus I to the power n. That is a reducing balance formula. So here now you have to find what is the A here, what is the P, what is all the unknowns. Do you have them? What are you asked to find? Calculate the book value. I mentioned once, in depreciation problems, this A is called book value or scrap value sometimes. That means the depreciated amount. So you are finding the A here. So that means you must have a principal amount. The cost of the tractor now at present, it's 980,000. Okay, the interest rate is 9.2%, per annum. N number of years in this problem is 7 years. So it's just a matter of substituting here, that is A equal to 980,000 times 1 minus 9,2% to the power 7. Put this as it is in the calculator. You must put exactly like this in the calculator. 980,000 bracket 1 minus 9,2 percentage. Don't forget to put the percentage also. It is also available in the calculator. So put the percentage sign as well. Some learners do forget. So if there are those learners who forget to put percentage, you change it here itself. You put 9 over 9,2 divided by 100, which will give you 0,092. You can do that, or you put percentage as it is in the calculator to the power 7. So this is the final answer. I have written the answer here. So let me write that value. It's going to be 498,685, comma 82. That is answer. So you have already seen now that is a tractor that was bought for 980,000 became 498,685,82 because it was depreciating for 7 years. Now always make sure that you round off to 2 decimal place, because in financial maths it's rands and cents. So always round off to 2 decimal place. And also the financial maths values must be accurate, so it's better to use the calculator only at the last step of your calculations. So here there was only one step, so you put as it is in the calculator, this one. Okay, I hope you also got to this answer. Let's go to 8.2. How many years will it take for an amount of 75,000 to accrue to 116,253,50 in an account earning interest of 6,8% per annum compounded quarterly? So this word simply means accumulate. That is the meaning of that, or arise. That is the meaning of it. So what happens is an amount of 75,000 will increase to 116,253,50 in how many years? We don't know. That's a question. How many years will it take to change this to this amount? Interest rate is given 6,8% per annum compounded quarterly. Okay, now let me remind you what you learned in grade 11. How do you handle this quarterly? So if the question says quarterly, you don't forget to divide the interest rate by 4, at the same time the number of years by 4. Meaning of this is interest rate is taken every quarter. N times 4 means you are changing the year to quarters now. There are 4 quarters in a year. That's why you'd multiply this by 4 and divide I by 4. Now if the question says monthly, compounded monthly, so all this, all this is about compound, the interest rate compound. You do this when the question says interest rate compounded quarterly, compounded monthly. Then what you do is you divide the I by 12 and you multiply the n by 12. Now if the question says semi-annually, or sometimes it's half yearly, both same meaning, half yearly. Then you divide the I by 2 because 2 half years in a year, and you multiply the n by 2. Okay, semi-annually or half yearly. So that is just a reminder about your grade 11 work. Let's go to 8.2 now. I think because you can see the question here, let me write here the answer for 8.2 as well. So 8.2, how many years will it take for an amount of 75,000? Okay, so we already decided on the formula. It's going to increase. So it's A equal to P. It's a plus formula. Now, how do we know if it's a plus IN or A plus I to the power n? Because it says compounded quarterly. So that means it's a compound interest formula. P times 1 plus I to the power n. So A is the future amount in the compound interest formula, which is 116,253,50 equal to 75,000 to the power 1 plus interest rate is 6,8% compounded quarterly to the power n we don't know, but because it's number of years, you multiply by 4. Okay, so this is the question. Now here the only unknown is n. That's what we are finding, number of years. So how do we get to there? So first step is you divide, you have to remove everything one by one. So first we are removing 75,000 here by dividing by 75,000 on both sides. Okay, then this get cancelled. Here you leave it like this. As I told you, in financial maths accuracy is very important, so we are so here what after dividing, what is remaining here is 1 plus 6,8% divided by 4 to the power n. So here it's in the form. Now let me just write here what you have got now is in this form. A equal to b to the power n. The unknown is in the exponent. So this is where you use the logarithm, that is n equal to logarithm of the base of a. So this is what you need to remember in here now. Okay, so that's what we have. So here on top of what you have is not n, it's 4n equal to log. The base here is 1 plus 6,8% divided by 4. That is a base only. So here this is the value here. In the place of a you have all that fraction. It's better you write them as it is, because you take your calculator only once. Divided by 75,000. So you can maintain the accuracy by doing this. So now your answer will be 4n. If you put this in the calculator, you use the log button. You use the button log this in the calculator, this button in the calculator. So when you use the log button, you get equal to 25,999 etc. Dividing by 4 on both sides, you get n equal to 6, rounding off to 2 decimal place will give you 6,50 years. That is answer. Okay, so these two questions for 7 marks were from grade 11. We used the A1 minus the depreciation formula and the other formula for compound interest. Okay, these are common questions in the exam from financial maths. Now we are going to, that means now the next part of the question will be annuity questions. So let's see. So here when you were reading these questions, you could see that you must also do this in the examination to decide on the formula. Compounded quarterly tells you that it's the compound interest formula. Okay, now Tabo wanted to save 450,000 as a deposit to buy a house on 30 June 2018. Now he deposited a fixed amount of money at the end of every month. So here what is important is end of every month. That means it's an annuity formula, end of every month. So that tells you that now you're going to use those two formulae in the bottom in the formula sheet, F or P. It is a future value formula, but before we start with the future value formula, you have to remember certain things, especially the n value, number of payments. That is only one thing to be very careful in future value formula. So that I need to give you some examples before you understand the importance of n. We will see this in the next video because otherwise this video is going to be very long. So I'm going to say everything about the future value and the present value formula in our next video. That will be part 2 of financial mathematics. Thank you very much.